Now we'll look at combination of errors. Suppose you got more than one reading and all of them are having some errors. Then how do we handle those errors in different mathematical operations? First, let us look at addition and subtraction. If Z is equal to A plus minus B, it can be either addition or subtraction. Both are similar things. When Z is A plus minus B, error in Z is equal to error in A plus error in B. This is very important to understand. Errors are always added. Errors are never subtracted. If we do two mistakes, the errors will get added up. One error cannot cancel the other error. Suppose A is equal to 5 plus minus 0.1. B is equal to 3 plus minus 0.2. Now what is A plus B? A plus B, we first add the numbers. So 5 plus 3 gives us 8. And what is the error in this? We add the errors. We add the absolute errors. We get plus minus 0.3. Now what is A minus B here? A minus B, we have to do the subtraction operation. So we subtract 5 minus 3. So what do you get? 2. But the errors will not get subtracted. Errors will still get added, then we'll get plus minus 0.3. So this is how we handle errors in addition or subtraction. Remember, errors are never subtracted. Errors are always added. Now let us look at errors in multiplication and division. If Z is equal to A into B, or Z is A divided by B, in both cases, fractional errors will get added. In the earlier case of addition and subtraction, absolute errors were added. Now in this case, fractional errors will get added. Suppose you to multiply those two numbers, A and B. So what do you get? Z equal to AB. So we multiply A and B, simple mathematical operation. We do the multiplication without bothering about errors. So what do you get? 5 into 3, 15. Now how to find the error in Z? Now fractional errors will get added. So delta Z by Z will be delta A by A plus delta B by B. So what is delta A? Error in A. So we get 0.1 divided by 5. And what is error in B? Fractional error is 0.2 divided by 3. So now we can do the mathematical operation. We will get 1 by 50 plus 2 by 30. And we can find the fractional error. So when we are doing multiplication or division, remember fractional errors are added. What happens when we have a power? Suppose Z is equal to A to the power M, B to the power N by C to the power P. So what will be the error in Z if you know the errors in A, B and C? The power becomes the coefficient. So error in Z by Z will be M times error in A by A plus N times error in B by B and P times error in C by C. So here the power becomes the coefficient and then the fractional errors come in each term. Let us say A is equal to 2 plus minus 0.1 and B is equal to 4 plus minus 0.2, whatever units. And we have to find out AB. So first we find out AB, A into B, without bothering about errors. So 2 into 4 is 8. So AB will be 8 plus minus something. Now, in multiplication and division, fractional errors are added. If AB is equal to Z, delta Z by Z will be equal to delta A by A plus delta B by B. So what is delta A? 0.1. And what is A? 2. Delta B is 0.2 by 4. So add these up, what do we get? 0.1 by 2, this is also 0.1 by 2. So 0.2 by 2. 0.2 by 2 is 0.1. So this is the fractional error in Z. So now we can find out the error in Z. Delta Z by Z is 0.1 and therefore delta Z is 0.1 into Z. 0.1 into Z will give us 0.8, right? So therefore the final result is Z equal to 8 plus minus 0.8. So this is how we handle errors in multiplication. Fractional errors are added. Suppose you to find out B by A. So what will be B by A? Don't worry about errors initially. So B by A is, B is 4, A is 2. 4 divided by 2 is 2. Simple. Now, the fractional errors again will get added. Errors are never subtracted. So whether we are doing addition, subtraction, multiplication, division, errors will always get added. So what do we get? The same thing is valid because delta A, delta B, B, nothing has changed. So 0.1 is a fractional error. So therefore, this Z, delta Z by Z will be equal to 0.1. So delta Z is 0.1 into Z, that gives us 0.2. So therefore in this case Z will be 2 plus minus 0.2. So this is how we handle errors in multiplication and division. How do we handle errors in power? Suppose Z is equal to A to the power M, B to the power N divided by C to the power P. In this case, this power will become the coefficient. So error in Z by Z will be equal to M times error in A by A plus N times error in B by B plus P times error in C by C. So error in Z by Z is equal to M times error in A by A, N times error in B by B plus P times error in C by C. This is how we handle errors in power. Suppose we have to add up two volumes. Suppose volume 1 is 4 plus minus 0.1 meter cube. Volume 2 is 6 plus minus 0.2 meter cube. So what will be V1 plus V2? When you are adding or subtracting, absolute errors are added. So V1 plus V2 will be equal to 10 plus minus 0.3. So this is how errors get added in addition. In subtraction also errors will get added. V2 minus V1 will be equal to 6 minus 4 is 2 and plus minus same 0.3. Remember, whether we are adding or subtracting, errors are always added. Now let us look at some problems on errors. Suppose the volume of one object is 4 plus minus 0.1. The volume of the second object is 6 plus minus 0.2. So what is the sum of these volumes? So V1 plus V2 we want to find out. So when you are adding volumes, it adds the volumes. So 6 plus 4, 10. And the errors also get added. So we get 0.3. So this is the sum of these two volumes. What is V2 minus V1? V2 minus V1, we subtract the volumes. So 6 minus 4, 2. But the errors are still added. That is very important to remember. Errors are never subtracted. Errors are always added. If you do two mistakes, both the mistakes will always add up. They'll never get subtracted. So therefore this is 2 plus minus 0.3. So now we have seen how errors get handled in addition or subtraction. Now let us look at multiplication. Suppose the mass of an object is 15 plus minus 0.3 kg and the volume of this object is say 5 plus minus 0.1 meter cube. Now to find the density of this material. So how to find the density? All of you know how to find density? Yes, density is mass by volume. So that is very easy. Mass is 15, volume is 5. So density becomes 3 kg per meter cube. But this is without errors. Now you have to find errors and give the answer. So how to find errors? Right, in multiplication or division, fractional errors are added. So error in density by density will be equal to error in mass by mass plus error in volume by volume. So what is error in mass? Error in mass is 0.3. So this we divide by 15. And what is error in volume? 0.1. And that is 5. So what do you get? So we get this as, this is 0.1 by 5, 0.1 by 5, if you add up you get 0.2 by 5. That is 0.04. So this is the fractional error in density. So what is the error in density? We multiply that by density. So what do I get? Delta rho is 0.04 into rho, 0.04 into 3. So get 0.12. We can note off to one decimal place. So error in density is 0.1. Therefore density we can write as 3 plus minus 0.1 kg per meter cube. So this is a problem where we have got handled errors in division. Let us look at a problem involving power. We have learned that there is a famous equation for simple pendulum. Time period of a simple pendulum is given by 2 pi root over L by G. Right? All of you know this. So this is nothing but 2 pi L to the power half by g to the power half. Square root is nothing but taking power half. So now error in t by t will be half times error in L by L plus half times error in G by G. So this is how we'll find the error in time period, the fractional error in time period. Suppose a problem is given to us where length is measured with 1% error and G is available with 2% error, and they ask us what is the percentage error in time period. Percentage, all you can multiply by 100, all the terms we can multiply by 100 and get the percentage error. So the error in length was 1%. So half into 1%. The error in G was 2%. This gives us the percentage error in T. Therefore, 0.5 plus 1, 1.5% is the error in time period. That's all. In multiplication or division, fractional errors are added. In addition or subtraction, absolute errors are added. And whenever powers are there, those powers becomes coefficients in the terms involving fractional errors. That's all that is there in errors. Errors are very simple to handle. Thank you.